Okay, so this section, we're going to learn about limits and continuity. Now, here's the difficult part. So let me just explain to you what makes this a little tough. Okay, so here's, uh-oh, I don't want that. I want black. Okay, so here's my situation. I have this function. Okay, so this is the function y is equal to f of x. So I can ask you, what is the limit as x approaches 3 of f of x? And you will say, well, as I approach 3 from the left, so if I'm going from the left toward 3, I see my function is approaching 7. And if I go from the right to 3, I see my function is also approaching 7. So that is 7. Then I can ask you, what is f of 3? Oh, I didn't tell you what f of 3 is. F of 3 is 3.5. Okay, so f of 3 is 3.5. Okay, so now based on this, we see that the limit exists, that we can see, but the function is not continuous because it fails the continuity test. Remember, for the continuity test, three things must happen. So f of a has to exist. The second thing is that the limit as x approaches a of f of x has to exist. But third and most important is that the limit as x approaches a of f of x has to actually equal f of a. So once you show the two things exist, they have to be equal. So for this function up here, the limit exists because from the left, it's going, I'm sorry, from the right, it's going to 7. From the left, it's going to 7. So the limit is 7. The function value, however, happens to be 3.5. So they are not equal. So therefore, this function is not continuous. So we have a limit, but we can say that this function f of x is not continuous at x equals 3. Okay. Do you remember all of that? And does that feel comfortable to you, Anaya?
The limits, yeah.
The limit and the continuity test.
Oh, continuity.
Okay, so you can see that where there's a hole, if I were to try to drive through, I would fall in the hole because there's a hole there. So the limit exists because even if I'm going, if you and I are both driving toward the Grand Canyon and you get to one side and I get to the other side, we're both at the Grand Canyon. So the limit exists. We made it to the Grand Canyon, but there's this big hole. So because there's this big hole, it's not continuous. I can't reach out and shake your hand. So continuity says not only does the limit exist, meaning when I get there, we both get to the Grand Canyon, it also means the Grand Canyon's filled in so that I can shake your hand. So this problem is not continuous, even though the limit exists.
Okay. Because of the hole.
What's that? Because of the hole. Exactly, because of the hole. Now, this function is not continuous because the limit as x approaches 3 of the function doesn't even exist. Okay, this is a jump discontinuity. So that's as if I went to the Grand Canyon and you went to see Mount Rushmore. We went to two different places. So therefore, it's discontinuous. Okay, so we can have several kinds of continuity discontinuous functions. Okay, another function that's not continuous might look like this. That function's not continuous. Okay, now this one, the limit doesn't exist, that one doesn't either. So, but at least in 2D, in R2, it's easy to look at because you're only approaching it from the left and from the right. All right, now let's look at a 3D problem. Okay, so when I go to look at a 3D problem, so now we're in R3. So in R3, I have a X and a Y. So if I want to approach this point, so here's my point, X naught, Y naught. Okay. The problem is now I have some function floating over top. All right. And so maybe here's the value. That's the f of x, y, f of x naught, y naught, whatever. But guess what? You see how many different ways I can approach this? Instead of before, I could only approach it from the left and the right. But now, now I can approach this thing from this angle. I can approach it from this angle. I can approach it from this angle. Whereas up here, there was only one way, from the left and from the right. So now, where before we talked about the limit having some delta, some region delta, and then some space up here, epsilon, that we had to be inside of, and then we could get it inside of there, and we could say the limit exists. Well, now I don't have an interval around a point, I have a sphere around the point. Well, not a sphere, I have a open disk. So I need to be inside of that open disk for this function value to work. So here's what we get. So let's let z equal to f of xy be a function such that f picks up something in R2 and takes it to R. Okay? Then we can say this function f of xy approaches the limit L as xy goes to x naught, y naught, means the limit as xy approaches x naught, y naught of f of xy equals L. If for all epsilon greater than 0, there exists a delta greater than 0, such that whenever 0 is less than the square root of x minus x naught squared plus y minus y naught squared is less than delta, then the absolute value of f of xy minus L is less than epsilon, just like before, okay? So that just means that there's a small ball around the point that as long as I'm inside that ball, I'm within epsilon of the limit. Okay, so there's some really simple things. So for example, the limit as xy approaches x naught, y naught of x is just x naught. Doesn't matter what y is going to, as long as x is going to x naught, that's the limit. The limit as x approaches, xy approaches x naught, y naught of y is y naught, okay? And the limit as xy approaches x naught, y naught of a constant k is just a constant k. Something is wrong here. Yeah. Okay. Sorry. My computer, my tablet, the camera was still on. That ain't cool. Okay. All right. The limit as xy approaches 2, 3 of 2x plus 3y is 2 times 2 plus 3 times 3. Okay, nice and simple. Of course, those are always the easy ones, right? The limit as xy approaches 3, 3 of x squared minus x squared minus y squared over x minus y. Well, obviously that gives us 0 over 0. So I can do some more work with that. I can make that the limit as xy approaches 3, 3. I can take this as x minus y times x plus y all over x minus y. I can divide out this. And so then I just get 3 plus 3, which is 6. Okay, so just like we did limits before. Okay. So here's the theorem. So we want to say the limit as xy approaches x naught, y naught of f of xy is equal to L and the limit as xy approaches x naught y naught of g of xy that equals m. Then we get the sum rule. And the sum rule says if we take the limit of the sum f of xy plus g of xy, then that is just L plus M. And then this also gives us the difference rule. So I can put a minus under there and I get L minus M. Okay. 2, product rule. So I'm going to take this limit. And I have f of x times g of y, f of xy times g of xy. Then that is L times M. The constant multiple rule. So that is the limit of k times f at xy. Well, that's just k times the limit. Quotient rule. So we take the limit and now we have f of x over g of x. So I have f of xy over g of xy. And that's going to equal L over M, provided M is not equal to 0. Okay. And the power rule. So I'm going to do the limit. And so now I'm going to get f of xy raised to a power, m over n. Well, that's just going to equal L raised to that power. Okay. All right. So here's another example. I have okay. I want this to approach actually a number this time. So I actually want it to approach 0, 1. And the function is x minus xy plus 3 divided by x squared y plus 5xy minus y cubed. So now I just put in 0 for x minus 0 times 1 plus 3 divided by 0 squared times 1 plus 5 times 0 times 1 minus 1 cubed. So that's just 3. Okay. It is negative 3. Okay. And number 2. Of the square root of x squared plus y squared. And they are approaching, what did I write? 3, 4? 3, negative 4. 3, negative 4. So this turns out to be the square root of 3 squared plus negative 4 squared. That equals 5. Okay, let's try another one. Number 3. Notice all of these work out nicely. We haven't gotten to anything ugly yet.
That's good.
Of course, that comes next. Okay, you do all the pretty stuff and then you get the ugly stuff. Okay, x squared minus xy over the square root of x minus y, square root of x minus the square root of y. And that gives you 0, 0, because this is approaching 0, 0. Okay. So that's going to equal for some reason, if I keep writing the same thing over and over again, it gets sloppier and sloppier. So that's why I try not to keep writing the same thing over and over again.
That's why you copy and paste it.
That's why I copy and paste, because it just gets worse. And by the time the last written of it, it's like, I don't know why that happens. My hand's like, okay, I'm tired of writing that thing. Okay, this is again 0, 0. So now I'm going to take x squared minus xy divided by the square root of x minus the square root of y. And I'm going to multiply by the square root of x minus the square root of y divided by the square root of x minus the square root of y. Okay. So that becomes the limit again. I want 0, 0. So let's simplify this. So I get x squared. Actually, I'm going to factor out the x. So I'm going to get, but I was factoring out an x. Brain, come on, brain. X times x minus y times the square root of x minus the square root of y. And in the denominator, I get x minus y. So now I can divide this out. And this now becomes the limit as I approach 0, 0. Of x times the square root of x minus the square root of y. And that is 0 times 0, which equals 0. So far, all of them have been beautiful. Okay, so now's when it starts to fall apart. And it usually falls apart when powers aren't the same. So these other ones up here were just simple plugins. They were easy, they factored, they were pretty nice. Here comes the hard one. What is this, number 4? Yeah. And so only the hard ones are the ones that you're going to really see. Okay, I'll give you an easy one just to give you some points, but then you're going to have to figure out the hard one. That's what always happens. You get an easy one just so I know that you know how to plug stuff in. And then I got to give you a hard one, so I got to make you work for it. And this is over x squared plus y squared. Okay, so now what I want to find is the limit as this thing approaches 0, 0 of f of x, y. Okay, so all the other ones we did were direct substitution. You just plopped it in, you figured it out, direct substitution, got 0 over 0, factored out something. Okay, so again, as I said to you before, this is this scenario. So in the XY plane, not talking about what's floating over top, but in the XY plane, I'm trying to approach this point right here. And so there are numerous ways to get there. I can go this way to get there. I can go this way to get there. Of course, that doesn't have an arrow. I can go this way to get there. I can come straight down here this way to get there. I mean, there's so many different ways now I can come at this point. And the problem is no matter which way I come at this point, all of the answers have to give me the same thing. Okay, so I have to get the exact same answer no matter which way I come at that point. I got to get the same answer. Okay, if I don't, then something's wrong. Okay, so the trigger here is when I look at this, I see that this is 2 x's, x times x. This is y times y. This is x times y. Each one of those are on the order of something squared, whereas this thing is a cubed. So that's the indication right away that something's not going to work. But let's take the limit along a couple of different directions. So let's take the limit along the x, the limit, don't write it out. Along the x-axis. So when I take the limit along the x-axis, that assumes y is always 0. So therefore, when I do that limit, and I'm approaching 0, 0, the assumption is that y is already 0. So on this axis, y is already 0. So I can just see that the only thing moving is x. because y is already 0. So if y is already 0, this looks like x times 0 plus 0 all over x squared plus 0. So this is the limit. I'm taking the limit of 0. So I'm actually taking the limit because y already is 0. That limit is 0. So now let's take the limit along the y-axis. And that assumes x is 0. Okay. So when I do that, since I'm assuming x is already 0, this is 0 times y plus y cubed divided by x squared. Nope, x is 0. So divided by 0 squared plus y squared. So, oh, I actually get a limit now. I get something. The fact that x is already 0 and I'm going to 0, 0. Yeah. And now I have y cubed over y squared. So that just gives me y. And if y goes to 0, I get 0. So we're so obviously along the x and y axis, I'm good. Now let's try something different. And I'm just going to choose this out the blue. Don't ask where I came from, but let's just take the limit along the line y is equal to 2x. Now, why did I pick that? I picked that because that could be, it could be this one. That could be y equals 2x. I don't know. It's just any one of those lines that are going into 0, 0. So now I have limit so y is equal to 2x. So in the place of y, I have x, and I'm going to have 2x. And now this is approaching 0, 0. And everywhere I have x, I'm going to leave it. And everywhere I have y, I'm going to put 2x. So I have x, and then y gave me 2x. And then I have 2x cubed. And then I have x squared plus 2x quantity squared. Okay. So this becomes the limit as x 2x approaches 0, 0. So now I have 2x squared plus 8x cubed divided by 5x squared. So now that is the limit as x 2x approaches 0, 0. And that turns out to be 2/5 plus 8/5 x. And that turns out to be 2/5. And that is a problem because now I have the limit, I have something else. So all of that means that the limit as xy approaches 0, 0 of f of xy does not exist. Because I have to get the same limit from every direction. Okay. Here's another one. F of xy is equal to 2x squared y over x to the 4th plus y squared. Now that's another one indication. That's a power of 3, a power of 4, and a power of 2. And looks like it's not really going to work. So if I do the limit along the x-axis, limit along the x-axis, y is equal to 0. When I do that limit, you will see I will get 0. Yeah, because that's the limit. X is 0, so I get 0 over x squared plus 0, and that is 0 before you even take the limit, so that's just 0. Well, let's say I do the line y is equal to y is equal to 4x. Then my f of x, I get the limit y is equal to 4x. So what does my function look like? I get 2x squared, y is 4x, divided by x to the 4th plus 2x squared. Oh, I thought I'm wrong. I want kx squared. So I want this to be a squared. And then I want this to be a squared. So now they're all the same power. So that becomes the limit now I get x for x going to 0, 0. And I have 8x to the 4th in the top, and I have 5x to the 4th in the bottom, so I get 8/5. Again, they're not equal, so the limit does not exist. Okay, so that's limits. Then we go on to continuity. And we have the continuity test. So we say f of x is continuous at the point x0, y0 if 3 things happen. Number 1, f of x0, y0 exists. 2, the limit as xy approaches x0, y0 of f of xy, it also exists. And 3, just like the other case, badam, 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 they are equal. So this is f of xy actually equals f of x0, y0. Okay. So the most difficult ones are like before, functions that are the most difficult are quotients, rational functions. So the most difficult are rational functions, square roots, logarithms. Okay. So, for example, so these are continuous functions. F of x, y equal to e to the x minus y, e to the negative x squared plus y squared, pretty much anything like that. F of x, y equal to the cosine of x squared plus y squared, f of x, y equal to the sine of x, y, f of x, y equal to the natural log of 1 plus a function of x, y, x squared, y squared. All of those are continuous. Not continuous. F of x, y equal to 2xy over, and we'll do this one, x squared minus y squared plus y squared. F of xy equal to the natural log of x squared minus y squared. So things like that. Okay, I'm trying to decide the next problem, but I think I'm going to stop there. Okay.
Okay.
And, we will
Tomorrow.
pick up tomorrow. Okay. All right. Bye-bye.